We're going to start off with some review again today. So in this first box, this is asking us to do some division. So 3y to the fifth divided by y cubed. So 3 divided by 1 is 3. And if I have 5 y's in the numerator and 3 y's in the denominator, remember that these 3 would cancel with these 3, and I would be left with 2 y's in the numerator. Again, that is just subtracting the exponents. In this second box, this is asking me to subtract these polynomials. So remember, we need to go ahead and distribute this negative sign to all terms in that. So that would become plus 2x squared minus 3x and minus 5. And then we need to combine like terms. So in this case, x squared and 2x squared is 3x squared. I can then combine negative 3x and positive 3x, which is just 0x, which then I don't need. And then I can combine 1 and negative 5, which is negative 4. So my answer is 3x squared minus 4. And again, that's still a quadratic because the highest exponent is 2, but it is a binomial because there's only 2 terms. Now, box 3 is something that we haven't done in a while and you might not have done ever. We have a binomial on top divided by a monomial. Now what's important to note is that I cannot just cancel this x to the fourth with this x to the ninth. This x to the fourth belongs to both of these terms. So what we're going to go ahead and do is we're going to write this out as 12x to the ninth over x to the fourth plus 4x to the fifth over x to the fourth. Because remember when we add fractions, we only add the numerator and the denominator is along for the ride. Now I can simplify this. This would be 12x to the fifth, and this would be plus 4x because 5x is here, 4x is here. That leaves me with 1 here. 9 here and 4 here, that leaves me with 5 there. Okay, so what we're going to do is we're just going to kind of recall kind of what happens when we multiply two linear binomials, and I just want to go through this a little bit slowly here. So what we're going to do is we're going to first go and do x times x, which is x squared. Then I'm going to do x times 6. I'm just going to draw it down here for a moment, and I'm going to write down plus 6x. And then I'm going to do 4 times x, and I'm going to write it here. And I'm going to do 4 times 6. Okay. Some people say that that kind of looks like a face, 2 eyebrows, a nose, and a mouth. And that's going to be important going forward here. So we notice here is these two middle terms will add together, okay? And that kind of came from drawing this little nose and this mouth, right? Those outside pieces and those two inside pieces. Because when I add these, then I get x squared plus 10x plus 24. It's important to note that this 24 didn't change and this x squared didn't change. And that's pretty typical if we have a linear binomial times a linear binomial. We're going to see the same thing happen here. So if I go ahead and do 2x times x, that's 2x squared. And if I go ahead and do 2x times 3, I get 6x. And then I'm going to do negative 5 times x. And I'm going to do negative 5 times 3. Now notice again that those two upper ones, these two, didn't change, right? Those are not going to be added together, okay? What's going to be added together is what's in the middle there, okay? And that comes from, and will always come from, this little negative 5x in here and 6x here, okay? That little nose and that mouth, okay? Because those two middle terms get added together, correct? Anytime we have a linear binomial times a linear binomial, those two terms are going to be added together. So what we need to do is we need to go backwards. So the first thing we need to ask ourselves is, do I have a greatest common factor? So when I look at this trinomial, is there some term number variable that I can divide out of each of those. So number one, look for GCF. And in this case, I don't have a GCF, okay? So number two is I'm going to identify that this is a trinomial that is a quadratic. And since it's a quadratic and a trinomial, best way to factor this is going to be some binomial times some binomial. If we think about where that came from, it typically always came from two linear binomials. So what do I need to think of? Well, remember, we talked about these two pieces being the good guys, right? Like the easy guys. I know that my yellow spot times my yellow spot is equal to that yellow spot. Okay? We know that. And we know that my pink spot times my pink spot is equal to that pink spot. Okay? Now, it doesn't always mean it adds to that positive x. So what we need to do is do what's like guess and check. So what I'm going to do is I need to get my yellow times my yellow needs to be 2x squared. Well, there's really only one option for that, and it's 2x and x. Now, it doesn't matter in this case when you start if you put the 2x on this one or the x on this one, okay? So just pick. Then I want you to think of numbers that multiply to 15. Let's just start with 15 and not negative 15. So when I think of 15, I have 1 and 15, and I think of 3 and 5, okay? So what I'm going to do is I'm just going to go ahead. I typically pick the numbers that are closer together, and I'm just going to put in a 3, and I'm going to put in a 5, okay? Now, so far, I know that 2x times x is 2x squared, and I know 3 times 5 is 15, and I know I need a negative, but let's just check to see if it's even possible to somehow get that positive x. Remember, that positive x comes from this nose and this mouth when we multiply. So let's check this out. This is going to give me a 3x, and this is going to give me a 10x. Now, I want you to think about this. These two are going to be added or subtracted together. Is there any way we're going to get positive x? No, we're either going to get 13, negative 7, or 7 when we add those. So they are probably not in the right place. So I'm going to go ahead and switch the 3 and that 5, and it's going to make a difference. If I put a 5 here and a 3 here instead, I now have 5x in the nose and 6x in the mouth. So let me ask you this. Can I get positive x somehow now? Can I get that positive x? And you know what? You sure can. How would you get that positive x? Well, we would want this negative 5. That would give me plus 1x. And in order that to be negative, this would have to be negative here, and this would have to be positive here. So the last step you need to do is rewrite it, and I need you to multiply that out and check to make sure it's correct. So when I multiply this out, 2x times x is 2x squared. 2x times 3 is 6x. Negative 5 times x is negative 5x. And negative 5 times 3 is negative 15. And guess what? We did it. So the factors are, or completely factored, is 2x minus 5 times x plus 3. So what were these things that we knew for sure? Well, we knew that the first term, the 2x squared, the x squared term had to come from the first two spots in the binomials. And we knew that the constant came from the last two spots in the binomial. Okay, the hard part is finding out that middle term and making sure it matches. Okay, so you might have to try a couple different combinations. Let's go ahead to this next page. Now, remember, what was the very first thing I said you need to do? And that is always check for a GCF first. So always, always, always check for a greatest common factor. Okay, and in this case, I see 6x squared plus 10x minus 4. And they can all be divided by 2. So I'm going to take out a 2, and I get 3x squared plus 5x minus 2. Now, I can't lose that 2. That 2 doesn't fall off the face of the earth. I now know I have a quadratic with 3 terms, okay? So I am going to I know I'm going to have a binomial times a binomial. Now, let's go back to that first situation we had. These yellow spots have to multiply to 3x squared. So I'm only got one option, and that's 3x and x, and I'm not going to move those. Okay, and then I have this negative 2 back here. So I know that this spot times this spot has got to be 2. Okay, so I'm going to lightly go ahead and just take a guess and put them in. If I put a 2 here and a 1 here, what I'm going to go do is check that little nose and that mouth. And what happens? Let's see. I get a 2x here and I get a 3x here. Now, we need to be very careful because that can give me positive 5x, but they would both have to be positive. Can they both be positive? No, they both can't be positive. And the reason they both can't be positive is then I would have positive 2 here. So I know that's incorrect. So I need to go change that. So I'm going to move the 2 to the other side and the 1 to the other side. And now when I check, I get 1x here and 6x here. Does that work? Can I get a positive 5x? And I sure can if that's a negative 1, positive 2. And then what we always need to do is go ahead and recheck and make sure that I did it correctly. So what we're going to do is don't forget about this 2. We're going to go ahead and do 3x times x, which is 3x squared. 3x times 2, 6x. Negative 1 times x, negative 1x. And then negative 2. And so far, it looks good. Go ahead and distribute that through. 6x squared plus 10x minus 4. And the beginning matches the end. So that is my final answer right here. And I'm going to highlight that and be done. So if I look at number 1, again, I need to ask myself, do I have a greatest common factor? And I sure do, and that is 4. I can divide all of those by 4. When I take out a 4, I'm left with x squared plus 4x plus 4. And then remember, I know I need to do a binomial times a binomial. I know that these 2 spots need to multiply to x squared, which that's going to be easy then. That's just x and x. There's no question about that. And that last spot needs to multiply to 4. Now, what's nice about this is all positive, so I know that these 2 numbers need to be positive. I can go ahead and put those positives in right now because I know they can't be negative. Now, my choices are 4 and 1 or 2 and 2. I typically like to start with the ones that are closer to each other, so let's go ahead and check that out. Let's check the nose and check the mouth. This gives me 2x and this gives me 2x. When I add those together, do I get 4x? I sure do. So I am done. I get 4 times x plus 2 times x plus 2. Now, if you're really thinking about that, you could also write that as 4 times x plus 2 all squared. So either one is acceptable, the shortened version or the longer one. In number 2, if I ask myself if I have a greatest common factor, that answer is no. So I know that I'm just going to start off with 2 linear binomials. Again, I need this first spot to multiply to 3x squared. My only options are going to be 3x and x. On the back end, I need it to be positive 8. So what's interesting here is some of you might be able to start to pick up that this needs to be positive 8, but when I add them, it needs to be negative. So both of these are going to have to be negative. Okay, if you don't see that yet, that's okay. My factors are 1 and 8 or 2 and 4. Okay, so I'm just going to plop 2 and 4 in here, and I'm going to see what happens. So when I do this nose, I get 2x. When I do this mouth, I get 12x. Can that somehow get me negative 14, yet still be positive 8 when I multiply? And it sure can. So you just need to make sure that both of them are negative, because that would give me negative 14x. And then what I would just carefully do is just go ahead and make sure that everything multiplies back up. 3x times x is 3x squared. We know we took care of the middle correctly, so let's just look at the end. Negative 2 times negative 4 is positive 8. So we have completely factored this. This is 3x minus 2 times x minus 4. If I look at number 3, I see that I have a GCF right away, and my GCF is 3x squared. 3x cubed divided by 3x squared is x, and 9x squared divided by 3x squared is just 3. Now, do I have a quadratic left in here? No, I don't. I have a linear binomial, so I'm done. There's nothing else to do. I can't factor that any further. So I'm done, and it's not bad to go ahead and check real quick. Let's just go ahead and check. Make sure we did this correct. 3x squared times x is 3x cubed. 3x squared times 3 is 9x squared. So we know that we factored that correctly. And the last one is number 4. So this one's going to be a little bit trickier because we've got 6x squared plus x minus 12. There's no GCF here. Now, here's why I'm saying this is a little trickier. This is the first time that first term, that leading term, has more than one option. So we can have 1 and 6. We can also have 2 and 3. So I typically like to start with 2x and 3x, okay? And then 12 is kind of a kicker too, because 12 can be 1 and 12, can be 2 and 6, and it can be 3 and 4. And it's a plus and a minus. So we've got stuff all over the place. So what's kind of neat to know is that if I have a 2 in here, I can't have another even number in here because that would make it have a GCF. So my only options to go in with this 2x is a 1 or a 3. I can't have the 4, 6, or 12. Okay? So I'm going to just try the 3 and the 4. I'm going to put the 3 here and the 4 here. And I'm going to see if there's any possible way. So when I get 3 times 3, I get 9x. And 4 times 2 is 8x, which is awesome because I do know I need to subtract them because one of them needs to be negative. So 9x and minus 8x, that would give me positive x. So that was awesome. I picked the right one. So this is minus and this is plus. Let's just go through and double check. 2x times 3x, 6x squared. Yay. 3 times negative 4 is negative 12. And we know in here that gives us positive x. So we know that our answer is 2x plus 3 times 3x minus 4. So one factor is 2x plus 3 and the other factor is 3x minus 4.